thank you for inviting me along. I spoke last year, and I guess when I was asked to speak last year at the Academics Conference, we were in a very different place to where we are now. The industry's had a lot of progress over the last year, and talking about these sorts of topics has become a bit more mainstream. Nevertheless, there'll be a few things that I'll repeat from last year, so apologies if you've heard some of this before. And obviously, there's a lot of overlap between what I'm about to say and what the other two speakers have just talked about this morning. I'm going to try and focus on as Catherine put it, the skills that graduates need or are going to need to go out into the world and design structures at the end of their degree courses, and hopefully frame it in a way that it helps influence your own thinking around your curriculums and how you teach them. I'm going to start, as I always do, by sort of recapping the big picture in terms of emissions and change and stuff like that. And the thing that really jumped out to me recently that I saw in the news is from The Guardian. You might not be surprised to know that I read The Guardian, but I do also read other papers too, is that there's more and more young people now making career choices based on the impact that they can have on global emissions. And there was another article in the BBC only yesterday, which didn't make it into these slides, that surveyed a whole load of younger generation and asked them how worried they were about the future, with over half of them responding that they're worried that humanity is doomed, in effect. So, the first thing to be cognizant of, and the big change that's happened in the last couple of years, is that the people you're teaching are in a very different place in terms of their mindset to where they were just a few years ago, and they want to go off into the world of work and do things about this. And hopefully, we can help convince them that engineering is a very well-suited place to go and do that. I thought this was worth it. I put this slide up for a lot of talks I do, but without the red lines on it. And I usually use it to try and convey the message that we need to, aim for a complete paradigm shift and a complete U-turn on the way that we do things around the world. But I wanted to do this with the red lines on it to also contextualize the world that these graduates are going to go into, because they're going to spend half their professional life in a world that's decarbonising, and then hopefully the second half of their professional life in a world that is either zero carbon or carbon negative. And we don't really know what the latter looks like just yet. The world of work they're going to enter is completely different to what any of us went through, whether we've always worked in academia or have done some time in practice. They really are in for, this is all new. And of course, the point of this is that they need to be a part of this, and they need to be told that they're going to be a part of this. There's no passengers on this train, because otherwise there's no way we're going to get emissions down as quickly as we need to. It requires everyone from graduate up to senior directors to be pushing in the same direction. In response to all of this, the industry is changing, and it's changing pretty quick. So this time last year, I wouldn't have been able to tell you much about what we're doing in terms of entry requirements to the institution. But since then, it's not just the ISRC that's taken a hard look at what the chartership requirements, but actually most of the construction industry as a whole. So the CIC, which is a forum for different institutions to speak to each other, they led the writing of a climate action plan that's been signed by 30 different institutions. And within that, it includes the requirement to revisit CPD, revisit initial professional development, revisit chartership requirements, and make sure that climate and carbon are at the heart of those things. I'm quite proud to say that the ISRC has already progressed this quite far. We've had board approval on changes that have been proposed to the chartered exam and to the IPD requirements, and we'll see that coming through from 2023. And without being able to give you too much detail on it, what I will say is that climate and carbon and reuse, things like this, they need to be, well, we all appreciate that they need to be core skills that an engineer has. And so the chartered member requirements are being updated to reflect that these are core skills. These are not a sort of optional extra. So expect to see carbon and climate literacy throughout both the exam and the IPD requirements. At the same time, whilst lots of good things are happening and lots of progress happening, your graduates will still leave university and go into the world of work and be up against a whole load of barriers that they're going to have to overcome. If they Google sustainable architecture, they still get met with pictures like this, where there are trees on buildings. And there's a lot of architects out there and a lot of clients out there who are still, pushing for this kind of architecture because they do believe that this is, the best we can do. Of course, it's not, and not only is it not the best we can do, it's also so misleading that it stops people from focusing on the bigger problems. And some numbers for you there: if you build 1 square meter of office, you emit a ton of carbon. You need to plant 10 square meters of forest to absorb that carbon back from the atmosphere over 50 years. So to put some greenery on buildings is, not going to get us anywhere. And we need our graduates to know this. We need them to be the ones who go out into the world of work and educate others on this, because it's not happening without them. We see more hypocrisy all over the media, because the architectural media still loves to talk about the biggest, tallest, shiniest, newest, which is somewhere that I think we will move away from over time, but we're not there yet. So instead of moving towards the most sustainable, we're somehow talking about the biggest sustainable building, tallest net zero, sustainability at new height with world's tallest timber buildings. These are all hypocritical statements. This doesn't work. This isn't, right. And again, helping our graduates understand that they are not going mad when they think that this doesn't make sense to them, but actually they're the ones speaking, the sensible things. And it is, I think it's just worth reassuring them with that sort of stuff. We also see, all sorts of greenwashing from all parts of material producers all over the industry. This is wood, but I've just picked that at random out of 4 slides that I've got in my usual presentation. I'd had to pick one, but we get the same from steel, concrete, and brick. They all tell you that what they're doing is as good as it could possibly be, as green as it could possibly be. And again, this is about creating students and creating graduates who have an inquiring, skeptical mind, who will go out there and say, fine, that's great, tell me why, show me the numbers, let me make my own decisions on this, so that they can then go off and design things in a way that is as low carbon as they think they can get it, rather than just being fed information by others. More examples, of course, of sustainable architecture not being sustainable. The most sustainable office building in the world, apparently, in 2017 was Bloomberg's headquarters down in London. But of course, what this was really referring to was its BREEAM credentials, and nothing at all to do with its embodied carbon. And if you look inside it and you look at the big black arrow drawn between columns there, and you maybe compare it to the height of that balustrade behind, that of course is about 1 meter or so above floor level, and therefore the depth of that staircase you're looking at is probably just short of 2 meters. You realize those columns are probably about 12 meters apart. And if you read quotes by the engineer and by the client on this, they'll tell you things along the lines of this statement on the screen, which is, in order to deliver a building of visual impact, steel tonnages were not seen as a limiting factor. So again, big statements about sustainability being made. There was more press over the summer about the Serpentine Pavilion claiming to be carbon negative. This is done with good intentions, and in the case of the Serpentine Pavilion, was done with good intentions and was sort of misinterpreted slightly. But the language that was used by the engineers who talked about what they'd done was not hot enough. It was not on the ball with exactly how they needed to be describing things. So again, this is an opportunity for our grads to come out better prepared than the people who they're going to go and work with. They're also going into a world where there's all these fantastic new technological advances left, right, and centre. 3D printed concrete and mass timber are my 2 favourites that come up again and again with people sort of claiming this is going to save everything. But of course, mass timber floors have about 5 to 7 times as much timber in them as timber joists do. And 3D printed concrete, I mean, who the hell needs to make a house out of solid concrete walls? I don't know. Are these actually lower carbon? Do the numbers, get your students used to doing the numbers, making their own decisions on these things. When is mass timber the right solution? When are joists the right solution? When is concrete the right solution? When is steel the right solution? These are the questions they need to be able to answer themselves. They also need to be aware, I think, of the differences that happen around the world on this topic. So, we're working in the, or I've been working in the UK for a while. And of course, the UK is looking at how we can, decarbonize the entire built environment. And there's a whole load of energy going into that, right from policy level down to your, grassroots engineers. Other countries are not coming at this quite as quickly or quite in the same way that we are. And so, the expectations for what a graduate could achieve if they get put on a project that's being built in Oman or China or Venezuela will be different to the expectations of what they could achieve in Norway or Canada or the UK. And that, again, they need to be okay with that. They need to be told, don't worry, you're not going mad. Of course they're going to be different, but then they need to understand the things that they still can achieve and the sort of role that they can play to make things better. I always put these numbers on the screen, so apologies, you've probably seen them before, but they need to understand the magnitude of what they're dealing with and the magnitude of the impact they can have compared to their friends. So their friends can skip a one-way flight from London to New York and save 1 ton of carbon, but this building on the screen in Canada, in downtown Toronto, that's being built, emitted just short of 500,000 tons of carbon, based off the back of a really quick hand calc that I did a few weeks ago. The difference between those means that if you do this 2% better, you can save 10,000 times as much carbon as if you skipped one flight to New York. And if your students aren't aware of these sorts of numbers and these magnitudes, please make them aware of it. They should be aware of this from the moment they step in the door in first year. Because if we go back to that slide I showed you at the start, where students want to go off and get jobs where they can make a difference, these numbers will convince them that they can make a difference if they stay in this industry. They need to understand the role of being a team player. We talked a bit about systems thinking this morning and understanding the holistic design. Of course, embodied carbon is not always the driver of the whole emissions of a building. And in some circumstances, you might even argue that carbon emissions in total are not the main driver of the whole building. There are, emergency hospitals being built in parts of the world that are being battered by storms, for example, where you might argue that actually resilience and making sure those hospitals stay open through the next storm is more important, and we can invest more carbon today. But again, it's about your graduates understanding that. It's about them understanding the time implications of these emissions. So it's about them understanding that emissions on site due to what you build today, whilst it might only be, say, 40% of the total, less than half of the total, in terms of emissions per year, is massive compared to anything else that a building, structure, bridge, whatever is going to see over the rest of its life. And so treat decisions appropriately. The grid is going to continue to decarbonize. That's going to happen everywhere in the world. The way we build buildings in the first place needs to change as well. And yeah, just the red bar on that shows you that, the structure is usually sort of 2/3 of that total. So again, really, really big involvement for them. They need to be equipped to deal with all of this. So they need the tools to be able to do this. And this is where the iStruct team has been working sort of tirelessly for the last 18 months. Most of what I've shown you in this presentation is freely available on the website. If you don't know where to go for it, you can drop me an email, I'll show you. This is a hierarchy that we use when I speak to engineers at all levels about design decisions that they take and designing for, well, this is a sort of net zero triangle on the left, which is why it includes offsetting at the bottom, but designing to minimize carbon and then offsetting the rest. The point with this, and the point I try and remind people of, is that you can't usually go back up this triangle very easily once you've started to work your way down it. But those decisions at the top will have the biggest impacts. Decisions at the bottom will generally have a smaller impact. Now, the fact that specifying low carbon over here, it comes after use less stuff, is quite important. What we're saying here is, you need to teach them that the material they build out of isn't the only job and doesn't solve all the problems. They need to answer all these other questions first, get their emissions down as far as they can, and then make sure that the way they work with the material, where it's specified, cement replacements, things like, sourcing of steel, things like that, that comes afterwards. You can't do this the other way around. Doesn't make sense. And of course, as you all know, there's a bit of a loop back through this sort of stuff, as there is in all design. Once you've decided on a certain material, you might go back and reassess whether or not some of the earlier decisions were the right ones. But it's that way around, it's not the other way around. You need to make them okay with challenging the brief. I understand that the new JBM requirements for education that are being enforced as of next year are going to require you to teach things like this to your students. How do they meet the client's brief more or less without building what the client's asking for? How do they give them the same outcome without necessarily giving them the output that they imagined in the first place? Which is, the big question. But there's plenty of, good examples out there. My favorite anecdote is of the civil engineer who's approached by an airport based in the UK and asked if they would bid on designing another car park for the airport. But actually, when they dug into why they're asking for this airport car park together with the client actually sort of realized that what they really needed to do was reshuffle some of their flights, because they were overfilling the car park once a day, every day, and with a slightly better timetable of flights landing, which could be achieved without sending planes a long way around or anything like that, they could just completely eliminate the need for a new car park. There are ways to do this. The problem is engineers are not being taught that it's within their gift to stand up and ask these questions. So that, that's something that they need to be given. They need to be taught that reuse is going to be the starting point for everything they do. If we think back to that graph where I showed you that the second half of their career is going to be zero carbon, that means they're almost certainly going to be working in a circular economy world for the second half of their career, if not before. That means when they design a new hospital building, because they're designing something in a region that doesn't have a hospital, they're going to be trying to work out how to build it out of pieces of material that have been taken out of other projects. This photo on the screen is from the Circular House, which was built as a demonstrator project in London in 2017 for London Design Festival. It was an Arab project, so it's one that I've put on the screen a lot of times since then. This was built out of components that after LDF was finished, they disassembled the project and sent all those parts back. Everything was taken apart. It wasn't custom designed in the first place. They worked out what pieces they had and they designed from it. That's the sort of skill set graduates are going to need. And if they don't have it, if they're being taught in Steel Structures 101 that the first thing they need to do is design a scheme and then work out how big the beams need to be, then they're being taught backwards. That's the way we were teaching 10 years ago. It's not the way you should be teaching now. It should be, here's a palette of materials that are available to you. What could you design from it? What scheme would you come up with for those pieces? And then they need to be taught about the power of getting the structural configuration or the structural diagram correct. These are two towers on the screen, both designed by the same firm. One designed in London, where there's no real wind and there's definitely no earthquakes of any significance. And the one on the right is in Taipei, Taiwan, which has some of the highest wind and seismic loadings in the world. They have more or less the same amount of steel per square meter in both of those buildings. And the reason why is because on the right, the brief that the architect set to the engineer was to say, what is the lightest steel tonnage you could possibly get me? What's the best configuration for my building? And everything was driven around that. Now, that was done for reasons of cost at the time, and couldn't be done for the tower on the left because of things like sight lines and the like. But the point is, you can achieve so much more if structure is driven first, and helping them understand that and understand the importance of that gives them a sort of skill that they can turn up with some confidence when they turn up to work and be able to say, well, hang on, if we did it better like this, wouldn't that make a difference? Obviously, you've all talked about loading before, so we don't need to go into it again. But if they're not aware what 5 kPa looks like, please make sure they're aware of what 5 kPa looks like so that they can tell people how bonkers they're being when they ask for it. And then they need reassuring that, of course, when you take that triangle from the start that's got your build nothing, build less, build clever hierarchy on it, even if the first decisions that were made were the wrong decisions, e.g. let's build a 42-story tower in a highly seismic, typhoony region of the world, there's still loads of other decisions to make. So build clever. How do we lay out the structure in the best way possible, efficiently? Can we design it to 99% utilization? And can we be okay with not having that sleep at night factor that so many of us are used to designing with? They also need to be aware, of course, that this is all part of a bigger, knotty, far more complicated picture. You cannot solve carbon if you don't solve equality, if you don't solve biodiversity, if you don't solve freedom of speech. These things do go together, and the more you read about it, the more obvious it becomes. Make them aware of this, yes, but also just reassure them they don't have to tackle all of it at once. This is about picking and identifying the areas they can have the most involvement with and striving to do the best they can in that area, knowing that others will take care of the rest. Last but not least, because I'm aware that we're a couple of minutes into questions, I just wanted to touch on the students that you might have who maybe don't want to leave and go off to design buildings for a living or design bridges for a living, but actually they want to stay in academia, because frankly, we're going to need quite a lot of that as well. And helping them understand the role they're going to have to play is just as important. So I'm going to do this with a graph, because if there's one thing I remember from academia, it was that graphs and equations are king. So yearly emissions on the y-axis, time on the x-axis. You can see I haven't updated this since last year. We have to get yearly emissions down to 0 by 2050. We should teach them the practical aspects of construction, so we should probably aim a bit before 2050 so we can be late. And the area under that graph equals our total emissions. We all know that. So if the area under the graph equal to total emissions, that's what we have to limit to stay within the IPCC budget for 1.5 degrees. That gives you a curve. It always gives you a curve. It's your 1.5 degrees looks a bit more steep than this. 2 degrees looks a bit less steep than this, but it's always concave. To get a 10% reduction on projects is pretty easy. You avoid the sleep at night factors, you design things to 99% efficiency. That's all you need to do. 25% reduction, if you get the right architects, engineers working together, and the architect can live with, maybe not having a big transfer structure over the ground floor lobby, or not doing some silly flourishes on the way up the building, just for the sake of making it look pretty, then you can easily find 25%. To get to 50% is really hard though. 50% based against business as usual at the moment. You need clients who are demanding better and architects and engineers who are united in delivering it. And you need them to drive each other again and again. That, I think, is about as far as we can get with what we currently know about, which means that there's a sort of line across this graph. And above that line is a design challenge, and below it is a research challenge. We published a paper in the magazine late last year, and you'll find it on our website under topic 6, Get Involved, which lays out a whole load of R&D objectives to match the carbon budget. Do please have a look at it, because there's a huge amount of work that needs to be done around design, construction, materials, public perception. And if those things aren't ready until 2030 for mainstream engineering, then the design world, will have tapered out its efforts by then. That stuff needs to be ready now. It needs to be tested out on small projects in the next few years and scaled up over the few years after. So there's a lot of work to do on that. I don't have time to go through the Give 'em Hope slides. So needless to say, if you go back through this slideshow afterwards, there's some good example projects on here that you can give to your students to reassure them that they can do all this stuff if they try. But I won't go through them now because we don't have time. And there's also some links to some good viewing over the COP season. The one thing I would highlight, and literally have highlighted, is that we're holding a climate emergency conference over 2 half days. So there's a morning session in September, there's an afternoon session in October. They'll be different on the 2 halves, but hopefully it means no matter where your students are in the world, they can dial into one half or the other as we do it live. That's obviously free. It's free for non-members as well. Please just encourage people to sign up. There'll be lots of good learning at that. That's it from me. Quick whiz through.